Let's start. So we had one talk yesterday, and I promised it to come with the additional details today. This is the talk where details will be there. And I think we should start with sort of a soft announcement of the other talk that will be in the afternoon today from NetPile about the Windows authentication evolution. But I want to start with like announcements from the previous year where Microsoft announced that they finally found a way to get use of NTLM down to get it better and secure for all users. And the way they want to do this is through more use of Kerberos. And the interesting part is in the announcement. So it wants to get two things, iCurb and local KDC for Kerberos. And I think Andreas can go with our shameless use of NetPile's slides for this and cover this bit of how this evolution would happen. I'm feeling a bit weird here because, well, I'm sure the same thing will happen later at the Ned's presentation. So I'm not sure whether we should look at this in detail or just skip over these slides. And it looks like Andreas is in some waiting room. So I don't know what that means. Andreas, can you speak? Okay. Can you cover these slides?
Hello, can you hear me?
Yes.
Did you already start?
Yes. Can you cover these slides?
Yes. So Microsoft had a presentation about the evolution of Windows authentication. And the idea is to give a quick overview about them if you haven't watched them already, so that we know what we are talking about, and also if you forgot something to bring it back. So normal Kerberos normally works that you have a connection to the KDC, the Key Distribution Center. You authenticate normally with your username and password there, or with another mechanism, and get a ticket granting ticket. And with this ticket granting ticket, you are able to get service ticket to actually connect to the service you care about. That means that you are in the same network as the KDC and also as the application server or the service you want to connect to. So what Microsoft calls it, if you have a direct connection to something, it's called line of sight, they name it line of sight. And often it is the case that you are somewhere with your notebook and you have a line of sight only to the thing you care about, the service you want to connect to. And actually, KDC or the service where you authenticate against, you do not have in the line of sight. It's beneath a firewall or a network, so you are not able to connect to it. And from experience, we also know sometimes that DNS is not configured correctly. And when this happens, you have a direct line of sight, but still you are not able to connect because you cannot find out the KDC. So to the rescue comes here an extension for Kerberos called IA-Kerb. It's an SP-Nego mechanism. And with IA-Kerb, the idea is that you do not have the KDC in line of sight, but the service you care about. And we could use the service we want to connect to as a proxy. And IA-Kerb allows that. So it will proxy our Kerberos tickets or communication through the service application to the KDC, which normally has a direct connection. And because of this, we can use Kerberos instead of falling back to NTLM here. As NTLM normally solved that for us before, but as we want to get rid of NTLM, the idea is to use IA-Kerb. So here in more detail, you can see we are sending a password request to authenticate, and the application server is then proxying it to the KDC. We get a ticket granting ticket. We use this ticket granting ticket again to get a service ticket. And when we got this, we can directly talk to the application server. So the same way as we have contact to the KDC, but it is just proxied.
Yeah, a small correction. It's actually not a password being sent, but the initial packet, the Kerberos packet being proxied over to get the TGT.
So, and in case we do not have a KDC at all, or we do not have a domain controller with a KDC, so we do not have an enterprise environment here, but we still want to connect to a service we care about. It could be an SMB server. Then the solution here would be to run a local KDC. So each machine has its own KDC running. And here we are more or less doing the same thing. We are talking to the service we care about, and this proxies the Kerberos communication back to us, and we forward it to the local KDC and have it exactly the same way as in the enterprise environment where you have a KDC, and it will just get the ticket, granting ticket, from the local KDC and do the same things here.
Yeah, and kind of coincidence, we have seen similar needs in the Red Hat enterprise Linux environments. And this came when a couple years ago we introduced support for OAuth to authorization and authentication through the Kerberos and other passwordless methods with FreeIPA. So it uses Kerberos, and immediately after we introduced this, customers and community started asking, can we get this working on the machines where you don't have FreeIPA, or in the environment where you cannot IPA. We also saw for a long time a need to get a support for the firewalls and lack of direct line of sight. And one of the examples is the Fedora project. All Fedora contributors use FreeIPA and Kerberos to get access to the package maintenance tasks and other services. But they don't have access or direct access to IPA domain controllers. Instead, they use the Kerberos KDC proxy over HTTPS to connect to it. And this is supported by MIT Kerberos. This is supported by Windows clients for quite a long time. This is not IA-Kerb, but it's one of options there. Also, we get a lot of pressure to have FIPS compliance, and environments where FIPS compliance is important, they basically outlaw NTLM or RC4, and recently, even SHA-1 based encryption types, and so on. So Kerberos is kind of a natural choice to solve many of these problems. And with the RFC 8009, which introduces the FIPS compatible Kerberos encryption types, SHA-2 based, it basically becomes kind of a natural point or gravitating point for the implementation of this. So we have been talking about this passwordless authentication with FreeIPA and presenting that last year. So there is a demo that I gave at sambaXP a year ago, and it basically implements or builds up on something we implemented in 2014, 10 years ago in MIT Kerberos KDC. This is radius-based backend that we used at that point to implement two-factor authentication in FreeIPA using the tokens. And basically, it's a radius pass-through mechanism. And the same mechanism was extended to provide a channel to communicate between client and KDC sides of the pre-authentication methods for OAuth authorization, and to FIDO2 recently, the plus keys. So typically, this is what you see with Kerberos. There's a lot of activity happening, and effectively, this shows how SSSD handles this, but it's about the same with Samba. If you replace this block with SMBD and other components, you get pretty much the same kind of operations, and this can be Kerberos KDC running anywhere. So I thought, okay, if it's anywhere, maybe we can join these two boxes and have it running on the same system, and just have this fact that you don't really need to have POSIX information for Kerberos KDC to run. It only concerns about principals. It doesn't need POSIX identities. So the tying of these POSIX and Kerberos identities happens at the domain controller side with the pack information in the Kerberos tickets, and then we can kind of find out what and how we do. Is this identity really makes sense on a particular system, and so on. And with the refactoring in MIT Kerberos 120, we also get packs issued, but it's a mini pack, and I will come back to that. So if all of this is kind of not a big thing to do, can we simply run it locally as well? So my main kind of goal was to reuse existing work we did in IPA and SSSD, use default Kerberos backend in MIT KDC, and configure standalone setup. So, okay, standalone setup that tries to at least provide the authentication for this. So let me get this authentication working. So I have a machine where I basically have this local admin user that doesn't have password defined in the system. The password is only defined as a key in the locally running KDC. And I'm using Cockpit to log into that system purely to allow Zoom to share this easily. Okay, so I logged in and I have this terminal. And as you can see, this user just obtained a ticket just at about the same time as I logged in. And I can do sudo. There is, it's a prototype, so I cannot do a lot of stuff here, but I can at least become the root, and I can show you that this system actually runs KDC on the localhost. So it's not accessible outside. It's only running here. I also run Samba, and what somewhere should there be Cockpit, but Cockpit actually runs through systemd socket activation, so you wouldn't see it here. So this 9090 port that you see here on my screen is actually running through systemd. Okay, this user, it exists in a local system, but the users, let me try to get the user brings. The user only has the Kerberos kind of principle defined in the Kerberos database. So I can see this local admin, and I see that there are keys associated with this user, and it requires the pre-authentication to work. So normal stuff for the MIT Kerberos thing. Okay, coming back to his slides. This configuration is doesn't require any changes in the MIT itself. It's purely a configuration. So I just set the options to listen on the local host. We use here a host name of the machine as a Kerberos realm, but really it can be anything. We can set some random stuff there. Users can be defined elsewhere in the system. They might be in Samba, they might be an exposed through Winbind, they might be in SSSD or in ITC passwd, as I had in this case, and exposed through SSSD in this case. And the names are the same as Kerberos principles. So here I use SSSD to handle Kerberos authentication for the users. And this already gives you password-based login, Kerberos-based login. If you have access to KDC, if you can get an initial ticket, then you can authenticate against all services running on this machine. So technically, if I would have on my workstation initial ticket, or copy the Ccache from that machine and try to use it to access Cockpit, I would get that access, or I get access to KUBs and so on. And I get this all handled, well, PalmSSS GSS handles the Kerberos ticket authentication so that I can get, for example, sudo without entering password if I have the Kerberos ticket. But in my current prototype setup, I have a slightly updated version of Samba libraries that broke PalmSSS GSS. What I get is that all these works transparently, the same way it works in FreeIPA, or the same way it works with Samba ID, or direct integration with Active Directory overall. And it works with all the pre-authentication methods that MIT supports. So for example, in this setup, I have PKI init, so I can use smart cards or certificates right away. I don't need to do anything. The PKI init is just one command away with CertMonger tool that uses a local self-signed C8 set up this all. Remember, this is local host, so no, nothing to trust except yourself. And it works with Samba in standalone mode. This work in progress. It's already in the Git master. We fixed some kind of issues here and there, and this is something I can show. So if I look at the ticket, I have a ticket, and I can use this Kerberos ticket to connect to Samba and see, well, the same files I see here as a local admin. And if I look at the Kerberos credentials cache, you can see that I automatically obtained this ticket to Sif's service. So SMBD works transparently with this. There's no problem anymore. It simply works. Well, in the file server kind of standalone mode, what you get is a kind of a combination of backends in Samba. So PassDB handles user information. In this case, I didn't create any kind of additional information for this user, so it's really a very basic one. But it takes the POSIX information from NSS, so from the system. And because the user has the same name in the system as the Kerberos principal, it is mapped to one-to-one, and then it works. But we have some problem, or we found some problem. So, Andreas?
Yes, Samba. So when we tried this the first time, it didn't work in the standalone mode or file server only mode because we got a PAC. And normally we do not expect a PAC, or we did not expect a PAC in this mode. And the PAC here normally contains multiple buffers, including the logon information. So normally when you get a Kerberos connection, then you have a PAC coming with it and logon information about the user, like username, the group memberships, and stuff like that. But in this mode, we only supported pure Kerberos realms and didn't expect a PAC. So now we got a PAC, and the reason is that MIT Kerberos 1.20 and newer now have a minimal PAC added to each Kerberos ticket. And the reason is that the PAC contains multiple PAC buffers with checksums and also a logon name. And these checksums are there to validate that you can validate the ticket, that it hasn't been tampered with, so there was no man-in-the-middle attack. And Samba was not able to parse this minimal PAC. But in the meantime, we added support for this, and it is in Samba for the next version, 4.21.
Right, and the thing is, the whole idea that you can use Kerberos with a standalone mode is pretty old. It is expected to be supported there. It's just that the MIT 120 did this change by adding PACs, and PACs were not expected because we only expected to have PAC if it has logon information. So the whole token that you can use for defining what this user is and what properties are and what group ownership, group membership, and so on is there. The other part is that was not expected by Samba is these 809 encryption types, which define the AES variants with SHA-2 HMAC. They are FIPS 140-3 compliant, but they are not supported by Windows yet. So that's expected that, well, Samba as Active Directory doesn't know about them. Well, FreeIPA and MIT Kerberos, they default for these new encryption types. Well, new is probably a strong word because this exists for several years already. And we found few interoperability kind of problems when we enable these encryption types, to the point that some of the checksums were not expected by Windows to come for the verification. The buffers were larger sizes with the SHA-2H mark than Windows expected, so we had to apply some semantics in MIT Kerberos to handle this. But with the fixes in Gitmaster, this now works transparently, also in like a FreeIPA environment or in this local KDC case. So if we have normal pre-authentication methods working, can we add other methods? For example, these passwordless methods from FreeIPA. Yep. And the way, as I said, it's done is that MIT KDC supports the Radius backend channel. This is really a KDC talking to a Unix domain socket. And if somebody answers on that Unix domain socket, then the pre-authentication method can send a Radius message asking for validation of the Kerberos principal with some information that the client side of the pre-authentication method passed in. And this is used for OTP implementation. And then we added this for IDP, so identity provider or auth2 based implementation, and for the FIDO2 or passkeys method. And the thing is, the way how IP implements this, it's a standalone daemon that gets socket activated by systemd. So it essentially just a daemon that handles the Kerberos sent Radius packet and responds with the Radius packet. So it can work behind normal MIT Kerberos KDC. The only thing is this daemon is looking up data in LDAP server that FreeIPA provides. So all we need is to basically refactor this daemon to use local configuration instead, or maybe use something like passdb to pick up the information that otherwise is stored in LDAP. Obviously, we don't want to run LDAP in this local KDC case. We can use just a local database. So that's what we are doing. It's work in progress. Sadly, I cannot demonstrate until I fully replace this LDAP kind of lookup with the local configuration file. But then all these methods will become used and will become accessible. So because of this kind of configuration that we started with, okay, can we remove NTLM? We came to the point that we can replicate passwordless Kerberos for non-enterprise environments, or make these non-enterprise environments use of authentication as well, and it becoming kind of interesting. Then Microsoft announced IACurve kind of revival, and that became also interesting. So IACurve is an extension in GSS API. So out of the existing free software Kerberos implementation, it's implemented in MIT Kerberos. They have the draft version implemented, not a kind of a final one, because these IACurve activities, they kind of ceased several years ago, and it was not really used until last year when Microsoft announced this revival. It's not implemented in Heimdall, but there is a IACurb implementation in the Apple's version of Heimdall, which is in macOS configurations and so on, but it's specific to, it uses some specific macOS APIs to arbitrate which applications have access to IACurb and which are not, kind of trusted, non-trusted setup. So the way how it's done, it's very simple from the application developer's point of view. It's using different mechanism OID in the negotiation for GSS API. And if you look at the GSS sample demo, it basically replaces Kerberos OID with the IACurb OID when client talks to the server, and server does the same. If you launch the server with this -IACurb option, you will get the same. Well, obviously, this expects that the application uses this change or accepts this particular mechanism OID in its negotiation. And obviously, Samba hardcodes use of Kerberos. And as far as I know, everything else on the free software side actually hardcodes it. Or it uses no OID as a mechanism, leaving library to define what to use. MIT Kerberos actually does not use IACurb in its set of OIDs that it chooses to negotiate if you're not specifying the concrete mechanism OID. So it will not be triggered by default. So you have to modify applications. But that's okay. We can try and modify that. But there's another problem. So with the password-based things and the way how GSS API credential acquisition works, if you have credential and you have a password, you do something like GSS acquire cred with password and specify password, and that will work fine. But with the passwordless pre-authentication methods, you really need to have prompt exchanges. So you really get a response from the KDC side of the pre-auth method saying, please provide me this information. And client side of the pre-authentication method is supposed to tell user or ask the prompter interface, give me this information, like give me a password or give me insert your passkey device and press enter a pin if there is a need for verification, and then touch the device. So that's a bit complex one. Or for the OAuth, you really need to tell the user that the user needs to go to some website with their browser and do device authorization flow and so on. But this whole idea of prompting, it's not supported in GSS API. So GSS API, kind of the idea there is that you can maybe export contacts and import them in the other processes. And obviously, if the prompter is a function that or callback in the process, you cannot really guarantee that the exported callback can be called in a different application. And one of those important use cases is GSS proxy, which allows us to isolate access to the key tabs from the applications or encrypt credential caches. This very useful security feature. And that one uses GSS API import and export mechanisms to export context into a GSS proxy application from your application. So that wouldn't work, and we need to find some way. In addition, in the GSS API community, the idea is that the initial credentials that you obtain, you really obtain them with the raw Kerberos. You don't obtain them with GSS API. or you use credential cache with already active credentials. At most, you have key tab or password stuff. So we have password stuff working, but for this one, we probably wouldn't use or wouldn't be able to use iCurb this way. So an alternative is to use KDC proxy protocol. So MSK-KDCP spec defines it, and we have implementation of that. The one that IPA is using for more than 10 years now. It's supported by MIT Kerberos clients, and we use this on Fedora side for quite a lot. I think it's like 4 years now. All Fedora contributors are using that. And it's compatible also with the Windows clients they're using. But it's not supported by Heimdall. So Heimdall has this general problem with the TLS and certificate management. They still not decided how they would do that. But Apple has in their own Heimdall fork a support for KDC proxy with the integration to macOS certificate management subsystem. But it's broken. It doesn't support KDCP protocol because it doesn't talk to HTTPS actually. Well, the way it talks, it actually sends the tokens that are improperly formatted using a different KDC proxy protocol over HTTP and not HTTPS. But it can be fixed and so on. So all of this actually works with the raw Kerberos. It's just forwarding of the Kerberos, works with passwordless methods a lot. But of course, adding prompting to GSS API would help also to get this working with iCurb. There are no technical problems on the protocol level to make it like prompting working or exchanges of the pre-authentication working. So to get all of these things rounded up, we basically need to update iCurb implementation. I mean, it will probably work if we just consider MIT client and Samba built against MIT. We can easily get to the point that it's working. Samba client against Samba server. And that would be nice and easy, but it wouldn't work with the Windows implementation of iCurb. So we need to update upstream MIT Kerberos with this one. So I started discussing this with Greg, and it's still in the progress. There's just copious amount of time that we all have. What is nice to have, or would be nice to have in MIT or in Heimdall eventually, is to ability to run over Unix domain sockets instead of the IP or UDP, TCP or UDP. Have this done with socket activation, because that would allow us not to run KDC all the time, but not just activate when it's being asked. MIT KDC is relatively lightweight, but I can imagine people wanting to save memory overall. And we can probably extend the default KDB module to have basic local KDC support with better integration with the Samba standalone or domain member, just to make sure we can do seeds and proper logon info buffers there, based on the information the system knows about this user. So with this one, we can get to experience that would be on par with Windows 11 and Windows Server 2025 on this area. And Andreas?
Yeah, so on the Samba side, what needs to be done is that our SP-Nego implementation needs to recognize AA curve. That's probably just changing the or letting it know the OID so that it can establish it. Then in domain member and domain controller communications, we need to implement new netlogin functions, which have been added lately, and the documentation about it has been updated. So there is a server authenticate Kerberos function now. There is now pack validation and ticket forwarding netlogin calls. Then probably our client command line tools need to be adapted for IA curve so that you can also force the use of it or transparently use it so that it fallbacks correctly to whatever we want. And maybe when we have in a simple module upstream in MIT Kerberos, we might want to have more advanced KDB module shipped with Samba, which has the PassDB support, so that we could actually provide lock-on information pack buffer completely filled out so that it has a SID associated with it and group memberships. And then at one point, we probably want to add member support for multiple domains so that you can be enrolled as a domain member to an Active Directory domain, but also against the local KDC.
Yes, and that's all we have. Any questions, comments?
Jeremy here. Fantastic talk, you guys. So my comment on this or question is, when this rolls out and NTLM is officially declared dead, how easy is this going to be for somebody to set up? Because there's a lot of moving parts. And, you know, NTLM is horrible, but really simple. You basically add the user, USME password's added, you're done. Here, you got to configure Kerberos, there's just a lot of pieces. So how are we going to make this easy for people to use? Do you have any thoughts on that?
Yes. My aim is to get this as easy as it's done now with Realm utility, so Realm join thing, to that level. You run one command and you have it set up. That's ultimate goal, to have all the configuration done, maybe with the same Realm join, just specify one option on it saying local, and you get all of this. We know what needs to be done. So my prototype with this local KDC wrapper outlines what really needs to be done to set up this configuration. And it's frankly not much. So writing a simple utility that does this configuration automatically based on the template files is trivial. It needs to be done, but the most important part is enable Samba itself to negotiate our curve so that we can get it. For the password-based, that should be enough. Setting up KDC, maybe running it as socket activated so that you don't need to really set things up. You just need to run the utility so that it creates the Kerberos entries for host, for the user, and so on. That's it. And yes, this is the part of this work. Once it's done, once it's ready for the user, it should be one command and maybe a part of installer.
Okay, Alexander, I believe you, and it'll work on Fedora. Now do it on Slackware.
Maybe. Why not? I really don't see why they shouldn't work on Slackware or somewhere.
They don't have systemd, Alexander. I picked that as an extreme example,
but systemd here is just the part where I'm saying about socket activation, right? But
fair enough.
All I have here, it doesn't use socket activation. It's using the standard running Kerberos 5 KDC confined to run on a local host. What it wouldn't be working on right now is FreeBSD. FreeBSD is tied to Heimdall pretty deeply from kernel to user space. And until Heimdall has support for IOCUR, we probably wouldn't have any chance to do this.
Well, we can always ask them. So thanks.
Yeah. We can definitely have it working on the systems where we have MIT Kerberos and make it much easier than people think it could be.